Hey guys, so today we're going to be solving this very fundamental problem. I interacted with this question in Introduction to Mathematics of Physics, I think, or something like that. But it is, at the end of the day, a very simple ODE problem that is very applicable to many different questions. So to break down the problem we have at hand, this is the ODE that we are working with, and this is the boundary condition that we're given. So starting with the ODE, first I recommend rewriting it before you get started, just to really get acquainted with the question and really look at what it's asking for, which is to solve for yx. So just off the bat, you want to start isolating that yx. So our yx is right there and right there. So I'm going to bring the 10y onto the other side, because my goal right now is to get this D situation cleared as soon as possible. And to do that, you have to move something on the other side so that your D's are all on the same side alone. And we need to do that because now we can move this dx to the other side and do dy of x equals negative 10 y dx. Now remember how I said earlier that the question is asking for yx, so we want to move our y's on the same side. So we can move our y over here and do dy of x, so that's 1. And the other one is 1 over y, because we divide y on both sides, equals negative 10 dx. Now one way to solve this is bring the negative 10 on the other side as well, but I'm just not going to just because. And next we're going to integrate both sides in order to get rid of the d's. And in doing that, I'm going to rewrite the question to make it look more like a familiar integration question that we'll see. Oops. I'm just going to drop the x of the y of x just for simplicity purposes, equals negative integration of negative 10 dx. So now this looks much familiar and we're very comfortable with this sort of situation. So starting from the left side, we know that when you integrate 1 over y, or 1 over a variable, you get ln of that variable. So integrating the left side, we get ln of y. And then on the other side, we could pull out that negative 10, just to split this up into 2 steps. We could pull out the negative 10, integration of dx, and then we know that an integration of dx is the same thing as saying integration 1 dx, and the integration of 1 of dx would be x, so that we have negative 10x. So one thing here is that because we are integrating, we want to add constants. So that would be plus c plus c. But because c is an unknown variable, we could, c1, c2, we could add up the 2 c's into a third c. So c1 plus c2 equals c3. This is not work that you have to show. You could just go straight to that c3. I'm just showing you for simplicity or like understanding purposes. So if we pull the c1 onto the other side, we'll get negative c1 plus c2 equals c3. So we would have ln of y equals negative 10x plus c3. I'm going to drop the 3 just for simplicity purposes, and now we have ln of y equals negative 10x plus c. So our next goal, as we remember, is to solve for y. So what we're going to do now is to try to drop the ln. And as we know, when we want to drop an ln from a question, a little side thing, ln of x, we would put whatever, let's say we have this. We would put both sides up to an exponent of e, because e of ln of something just becomes that something. So we're going to do the same thing here. We're going to put e's on both sides, and we're going to clear that and get only y, and on the other side we have e to the negative 10x plus c. Now we could bring back our y of x instead of y, just so it looks a little bit closer to what we're supposed to find. And now we have this. Now we could simplify it one more time by breaking this down. So e of negative 10x plus c. As we know, with how exponents work, when a value is raised to another value plus another value, that is the same thing as that value raised being multiplied by that same value raised to the other thing. So this is just a rule of exponents. So we could apply that to this situation and simplify that into e to the negative 10x times e to the c. Now we could use the same trick that we used earlier with this whole situation and take advantage of the fact that our variable c is unknown. So for all we know, the variable of EC is just as unknown as the variable of C. So we could replace the e to the c with c. Or if you want to think about it, if that's too confusing for you, you could just pick a new variable and say it's d or whatever. But just for the casual schematics of solving this problem, we're just going to stick with c. So using this and replacing it back into our question, we get y of x equals e to the negative 10 of x times c. And the common way of writing this out would be putting the c first. So this looks very familiar to us, so we know that we're going in the correct direction. Oftentimes when solving engineering problems, similar things show up. So when you feel like you see something that looks a little familiar, you're probably going in the right direction. So this is where we bring in the boundary condition in order to solve for the unknown c. So we're going to bring that down. So we know that, I'm just going to rewrite the boundary condition that was given. This means that when x equals 0, y would equal 2. So we could apply that to our question and say, when x equals 0, dot dot, y of x equals 0 becomes 2. So CE negative 10, and now we know x is 2 equals 0. So I simply just plugged in this boundary condition into the equation we found, which gives us this. This is great because looking at this, we can see that the only thing we don't know is c, unlike earlier, which was c, y, and x. So now we could solve for our unknown variable. So we have 2 equals CE, and negative 10 times 0 is 0. And as we know, any value raised to the 0th power becomes 1. So I'm going to write that to the side. This is just a rule of exponents once more. So a lot of solving ODEs just comes down to knowing your basic rules. So sometimes it feels really complicating, but once you start solving it, it's very simple. So e to the 0 is 1, like we just established. So 2 equals c. So our unknown variable is 2. So now we have our equation, and thanks to our boundary condition, our unknown variable. So if we write out our solution all together, we get y of x. Once again, we're keeping the x, so it looks a little bit more similar to what was asked in the very beginning of our question, solve for y of x, equals CE negative 10x, comma, c equals 2. So y of x equals 2e negative 10x. And that is our solution. We solved it in a very step-by-step, over-explainy kind of way when you're actually taking the exam or in an in-person situation. You don't have to do it this slowly. You could drop a lot of the side steps that I did in order to solve this question really quickly. But I think when you're learning, it's very helpful to kind of solve it out slowly and be conscious of all the different rules that we're applying that feel a bit elementary, but when you're in an exam situation, you might freak out a bit about. So I think it's good that we went over it slowly and we're able to kind of reestablish that in our mind. Thank you for watching, and I hope this was helpful, and let me know in the comments if there's any more similar problems or different problems that you would like to cover.